So the natural log function, y equals ln stands for natural log of x, or you could write it log base e of x, because the natural log is the log with base e, is the inverse of the function y equals e to the power of x, right? So if you were to draw this line y equals x, since they're inverses of each other, they are symmetrical across this line, although this is not really the line y equals x. I tend to do that. See, yeah. So you can imagine if I were to flip y equals natural log of x over this line, it'd be y equals e of x, right? So it has that symmetry. So what is this number e? What's going on with this? What does that stand for? What does that mean? It's a very special number. It's a special number like pi. It's a number that occurs in nature and seems to show up everywhere. Well, it's basically the idea that um, there is a common growth rate of all things that grow exponentially and that grow continuously. In other words, it's not like um, I've got two bacteria, and then after 10 minutes, all of a sudden, boom, pop, two more pop into existence. It's more like over those 10 minutes, those two are becoming four. It's continuous growth, not discrete growth. So all things that grow continuously, um, like bacteria or money in the bank, um, they exhibit this pattern called E. So here, to kind of illustrate that, I've got a graph of the function y equals e. Like this is the value for e, which is roughly 2.71882818284590455235, but it goes on forever. And then I've got this function y equals 1 plus 1 over x raised to the power of x. Well, what does that mean? So you can see that the function approaches e in both directions, right? So this is very special. So e represents um, this asymptote here, this number that this function approaches as you go to positive and negative infinity. So what's happening here? What this really means is, let's say we take one bacterium. Bacteria reproduce by splitting in two. Mitosis. Here's a little, bacterium. Oh, it's starting to split, and then sooner or later, there's two of them, and then those two go on to, reproduce, and those go on to reproduce, right? But this process is continuous. It's not like every 2 seconds, boom, two more pop into existence or something like that. Okay, so say like we start with one bacterium. Um, After a full cycle of growth, after it has reproduced itself, we would say it's 1 plus 1. Okay, that's after a complete cycle of growth. So say it takes half an hour to complete this mitosis thing, and then after half an hour, there's two of them. Okay, but the question is, what about, how many bacteria are there after 15 minutes? Like, I don't want to just say, give me every half hour. I want to break this down into finer and finer segments of time. Well, I could split that growth cycle in half. I could say, so looking at this function, it would be something like, instead of 1 plus 1, it'd be 1 plus 1 over 2. But I'm going to do that twice because, uh, two half cycles of growth is a cycle of growth. So I could do that, or I could split the growth cycle into thirds. Say, tell me how many bacteria there are after 10 minutes out of the 30-minute growth cycle, and that's going to happen 3 times over those 30 minutes, etc. So that's what this is doing. Well, if you do that, you approach this number, and that is the number e, 2.71. So this is the maximum growth after one growth cycle of something that grows continuously and exponentially. So it's for this reason that the natural log, so log base e, is a very important one, along with the common log. Common log is base 10, and the reason why that is so used is that our number system is base 10. It's based on tens. Well, natural log is used all the time because this e thing pops up everywhere. It's just the rate of continuous exponential growth. So, okay, so hopefully that was semi-interesting. So the natural log of x is the inverse function of y equals e to the x. So as you can see, e to the x, as you go towards negative infinity this way, approaches 0. So its range is y is greater than 0, but and then less than infinity. So it goes goes from 0 to infinity, which means the domain of the natural log goes from 0 to positive infinity. So going this way, it approaches the y-axis here, which x equals 0, but never quite gets there. The range, on the other hand, is from negative infinity to positive infinity. So yeah, I think that's it. It's the basic idea of a natural log. It's asking the question, to what power do I have to raise e in order to get x? All right. Okay, there you go. See ya.